Imagine standing on the surface of a distant world, where the sky burns red at sunset, and twin moons rise over oceans older than anything on Earth. Imagine breathing air that isn't quite like ours, walking on ground that no human foot has ever touched, knowing that above you, somewhere in that alien sky, Earth is just a pale blue memory. For centuries, we've dreamed of finding another Earth, a second home among the stars. But dreams are easy. Reality is harder. Vast distances, unknown dangers, a universe that seems at first glance indifferent to life. And yet, we search. With telescopes the size of buildings, satellites drifting in silent orbits, and instruments tuned to the faintest flickers of distant suns, we scan the skies, asking the same question over and over. Are we alone? Or more precisely, is there somewhere else we could call home? Today, we're closer than ever to answering that question. Exoplanets, worlds orbiting other stars, are no longer just theoretical. We've found thousands. Some are gas giants, some are frozen wastelands, some are hellish infernos. But a few, a precious few, might just be right. They orbit their stars at just the right distance. They're the right size, the right temperature. They whisper possibilities, oceans, clouds, atmospheres rich with the ingredients for life. But how close are we really to finding Earth's twin? What would it take to live there, or even get there? And what would it mean for our future if we finally found it? Today, we're diving into the real science behind humanity's search for the second Earth, and the extraordinary journey that still lies ahead. So if you're fascinated by the cosmos, by the idea of life beyond this world, and by the future of humanity among the stars, make sure you hit that like button, subscribe for more deep space explorations, and drop a comment below. If we found a second Earth tomorrow, would you go? Would you leave everything behind? Let's find out how close we really are. Not every planet that looks like Earth from a distance is truly another Earth. It's easy to think that if a planet is about the same size, or sits in the right spot around its star, it must be habitable. But the truth is far more complicated and far more fascinating. Scientists call it the habitable zone. Sometimes nicknamed the Goldilocks zone, it's the region around a star where the temperature is just right, not too hot, not too cold, for liquid water to exist on a planet's surface. And since water is essential for life as we know it, this zone is the first place we look. But just being in the habitable zone doesn't guarantee anything. Take Venus. It technically sits within the Sun's habitable zone, yet its surface is a hellish wasteland, hot enough to melt lead, with crushing atmospheric pressure and clouds of toxic acid. Then there's Mars, which is also near the habitable zone, but today it's a frozen desert, barely clinging to a whisper of atmosphere. So clearly, the zone is just the beginning. For a planet to be truly Earth-like, it needs much more. It needs an atmosphere thick enough to regulate temperature, but not so thick it traps heat like Venus. It needs a magnetic field to shield it from deadly cosmic radiation. It needs stable conditions that allow complex chemistry to unfold over billions of years. It might even need plate tectonics to recycle essential minerals and maintain a stable climate. And then there's the star itself. Not all stars are created equal. Our Sun is a yellow dwarf, stable, relatively calm over long periods. But if a planet orbits a red dwarf, the most common type of star in the galaxy, it faces a new set of challenges. Red dwarfs are volatile, often blasting their planets with violent solar flares, stripping away atmospheres and bathing surfaces in lethal radiation. Even if a planet is technically in the habitable zone, surviving there might be impossible. Size matters too. A planet too small might lose its atmosphere and become a barren rock. Too large, and it could end up as a gas dwarf, a mini Neptune with crushing gravity and no solid surface to stand on. Even the presence of a large moon, like our own, could be crucial. Earth's moon stabilizes our planet's tilt, giving us relatively mild seasons. Without it, climate swings could be far more extreme, making life harder to sustain. So when astronomers say they found an Earth-like planet, it's shorthand. What they really mean is, it meets some of the basic requirements, but we still have a lot to learn. Finding a true twin of Earth, a planet with blue oceans, green continents, breathable air, and a stable, life-supporting environment, is staggeringly difficult. But that hasn't stopped us from trying. In fact, the search is getting smarter, faster, and more ambitious every year. And with new tools coming online, we're beginning to peer deeper into the galaxy than ever before, looking not just for planets in the right place, but for the subtle, delicate fingerprints of life itself. The real question is, how exactly are we finding these distant worlds? And just how much closer are we getting with every new discovery? Finding planets around other stars sounds like science fiction, but today, it's very real science. And the methods we use are as brilliant as they are mind-bending. The most common technique is called transit photometry. Imagine watching a star, a tiny point of light, from light years away. Now, imagine a planet passing in front of that star, blocking just a tiny fraction of its light. If you measure the star's brightness with enough precision, you can actually see the dip. It's like spotting a mosquito passing in front of a lighthouse from across an ocean. By tracking these tiny, regular dips in brightness, astronomers can figure out the size of the planet, its orbit, and even hints about its atmosphere. NASA's Kepler Space Telescope pioneered this method, leading to the discovery of thousands of exoplanet candidates. And Kepler showed us something shocking: planets are everywhere. More recently, the Transiting Exoplanet Survey Satellite, or TESS, has taken up the mission. Scanning nearly the entire sky, TESS is finding exoplanets closer to us, ones that might be easier to study in greater detail. But transit photometry isn't the only tool we have. Another method is radial velocity, sometimes called the wobble method. As a planet orbits a star, it exerts a tiny gravitational pull, causing the star to wobble ever so slightly. By analyzing the star's light, we can detect these wobbles and calculate the mass of the unseen planet tugging at it. This method gave us the very first confirmed exoplanet back in 1995, 51 Pegasi b, a gas giant orbiting close to its star. And then there's the dream: direct imaging, actually seeing the planet itself. It's incredibly difficult because stars are so much brighter than the planets that orbit them, often by a factor of 1 billion. But with specialized instruments like coronagraphs and starshades, we're starting to block out the starlight and glimpse these distant worlds directly. It's like trying to spot a firefly next to a spotlight from miles away and succeeding. The newest and most powerful tool in our arsenal is the James Webb Space Telescope. With its ability to capture infrared light, Webb can not only detect exoplanets, but analyze their atmospheres. By studying the light that filters through a planet's atmosphere during a transit, scientists can identify chemical fingerprints, looking for gases like water vapor, methane, carbon dioxide, and even oxygen. If we ever find a clear signal of all these gases together, it could be a strong hint that life, or at least life-supporting conditions, exist. And we're just getting started. Future missions like the Nancy Grace Roman Space Telescope and ambitious concepts like LUVOIR and HABEX could take us even closer to finding another Earth. Missions designed not just to detect planets, but to characterize them, to study their clouds, their oceans, their climates. Every new discovery sharpens our understanding. Every method reveals a little more of the hidden architecture of the galaxy. And now, thanks to decades of patient searching, we have a growing list of worlds that might just fit the bill. So which planets are the most promising candidates right now? And could one of them truly be a second Earth? Across the galaxy, scattered like tiny islands in an endless ocean, are worlds that whisper possibilities. Some are scorched deserts, others frozen wastelands. But a rare few, sit in that delicate balance between too much and too little, between blazing heat and eternal cold. These are the worlds that make scientists lean forward in their chairs, worlds that make us wonder, could we live there? One of the closest and most tantalizing candidates is Proxima Centauri b. Orbiting the nearest star to our solar system, just 4.24 light-years away, Proxima b is roughly Earth-sized and sits within its star's habitable zone. Sounds perfect, right? But there's a catch. Proxima Centauri is a red dwarf, prone to violent solar flares that could strip away a planet's atmosphere. Still, if Proxima b has a strong magnetic field, or if life there evolved differently, it could survive. And if nothing else, it's close. Close enough that future generations might actually dream of reaching it. Then there's the TRAPPIST-1 system, a family of 7 rocky planets orbiting a tiny dim star about 40 light-years away. 3 of these planets, TRAPPIST-1d, 1e, and 1f, are especially interesting. They're similar in size to Earth and sit within the star's habitable zone. Imagine an entire solar system where multiple planets could support life. A cosmic jackpot. TRAPPIST-1e in particular stands out. It's the right size, the right density, possibly even the right temperature. If it has an atmosphere, and we're still trying to find out, it could be one of the best places beyond Earth to look for life. Another strong candidate, Kepler 442b. Located about 1,200 light-years away, Kepler 442b is about 1.3 times the size of Earth and receives just about the right amount of light from its star. It's older than Earth, giving life plenty of time, if it ever began there, to evolve into something complex. Scientists estimate it has one of the highest probabilities for being rocky and potentially habitable among the planets we've found so far. And then there's LHS 1140b. At about 40 light-years away, it's a rocky super-Earth orbiting a red dwarf in the habitable zone. It's denser than Earth, suggesting it has a solid surface, and recent observations hint that it might have an atmosphere thick enough to support life. A world with water clouds, perhaps oceans, and the potential for biological chemistry to unfold. But here's the truth. For all the data we have, these planets are still mysteries. We can measure their size, their orbit, their star's radiation. We can guess, we can model, we can simulate. But we can't yet see their oceans, their skies, their mountains, or whatever strange landscapes they might have. We can't yet hear the winds across their valleys, or smell the air, or taste the water. And yet, even with these glimpses, we know something extraordinary. Earth-like planets are not rare. They're everywhere. The galaxy could be teeming with worlds where the ingredients for life are ready, waiting, perhaps even thriving. So if the candidates are out there, if second Earths really do exist, there's just one more question left to answer. Could we ever actually get there? The discovery of a second Earth would be one of the greatest moments in human history. But knowing it's there and reaching it, those are two very different things. Because space, as beautiful as it is vast beyond imagination. The nearest potentially habitable planet, Proxima b, is over 4 light-years away. That's about 40 trillion kilometers. With current technology, it would take us tens of thousands of years to get there. The fastest spacecraft we've ever built, the Parker Solar Probe, travels at around 700,000 kilometers per hour. Even at that incredible speed, it would still take over 6,000 years to reach Proxima Centauri. Clearly, if we want to visit these new worlds, we need something faster. Much faster. One of the most exciting concepts is Breakthrough Starshot, a project that aims to send tiny lightweight spacecraft, no bigger than a postage stamp, attached to powerful light sails, driven by lasers from Earth. If it works, these starships could reach 20% the speed of light and arrive at Proxima Centauri in just over 20 years. It sounds like science fiction, but serious scientists, including Stephen Hawking, believed it could be our best shot at reaching another star within a human lifetime. Of course, tiny probes are one thing. Transporting humans is something else entirely. Some have proposed generation ships, massive spacecraft where entire communities would live and die over centuries, traveling through the void with no destination within their own lifetimes. Generations born, raised and buried, all inside a vessel hurtling toward a new sun. Others imagine cryogenic sleep, putting travelers into deep hibernation for the long journey. It's an idea straight from science fiction, but research into suspended animation is real and making slow but steady progress. There's even more radical thinking. Propulsion systems based on nuclear fusion, antimatter engines, or even warp drives, bending the fabric of space-time itself to shorten the distance between stars. Today, these ideas are theoretical, but one discovery can change everything. Finding a second Earth could trigger a technological renaissance unlike anything in history. Funding would pour into advanced propulsion research. Nations might collaborate or compete to build the first true interstellar ships. And maybe, just maybe, the first human footprints on an alien shore won't be fantasy, but destiny. But even if we can never physically reach these worlds in our lifetimes, the discovery still matters. Because knowing there are other Earths out there changes everything. It means we are not limited to one fragile blue planet. It means life is not an isolated miracle. It's a pattern written into the fabric of the cosmos. It means our story, humanity's story, is just beginning. And maybe one day, centuries or even millennia from now, humans will stand on distant soil, look up at a foreign sky, and call it home. Finding a second Earth isn't just about survival. It's about hope. It's about ambition. It's about proving to ourselves that no dream is too distant, no journey too long. And it's about remembering that as tiny and fragile as we are part of something much larger than ourselves. The universe isn't silent, it's singing with possibilities. The only question is whether we're brave enough to follow the song. If you enjoyed this journey into the search for new worlds, make sure to like the video, subscribe for more deep dives into space, science, and humanity's future. And tell us in the comments, if you had the chance, would you leave Earth behind for a second Earth? Thanks for watching. Stay curious, the stars are waiting.